Okay, let's look at a solution for this this monster of a problem um, in the functions. What is a function's purpose? Lesson on Learn. So this is called split method. The name of the challenge. I'm not sure why we called it that. We'll probably change the name later. At any rate, this is here are the instructions. Fill in the functions that employ the below logic that prompts a user to enter a number. Note that you do not need to paste the provided code into the solutions editor, as the unit tests will only check the function logic. However, you will likely want to copy-paste the code into your editor in order to verify that your functions are working correctly. Now, let me show you what I'm talking about here, or what that's talking about. So we give some code, we provide some code, and we also provide the function definitions. Now, when you put the function definition, when you submit your challenge solution on Learn, you're only going to submit the function definitions, and you're not going to submit the code that we provided. Let's walk through this code that we provided. Now, first, notice that we have this prompt. This is what we would expect to give to the user who's running this application, right? Please enter a number, and I'll perform the following operations. I'll tell you if the number is a prime number. If the number is prime, I'll find the next number that's prime, and then we give like a little process there. And then if your number is not prime, I'll tell you all the divisors of that number, not including the number itself, and then enter your number. And notice here on line 19, we're getting user input, and these are the selections 0, 1, or 2. And so we get that input, and we have to cast it to an int, right? Because input always comes in as a string. And then we've got the isPrime function. If isPrime of the user input, then we're going to tell you that it's prime. Else, essentially, you can read through this on Learn if you want. But if it's not prime, we're going to say, well, it's not prime, and its divisors are this. So that's kind of the general format. I pasted this in from Learn, so I've got some artifacts of that. Let me just make sure. Yep, that looks good. So let me paste in our code, our function stubs. So we've got a find divisors function, an isPrime function, a find next prime function, and then we've got the placeholder code below. So you could go through this and solve just the functions, right? So that's fine. But having that prompt is nice. We can look at the different ways that you might build a menu, and I think that's there's some utility there. So let's just solve these one at a time, and I'm going to solve them one at a time using just some simple logic, and I'm going to comment out all of this prompt below because we don't actually need that to solve these one at a time. I'm going to give us some space. So let's look at this function definition. Find divisors. Let's look at the doc string. All integers that are divisors of n. Cool. So let's do that. Let's just take a basic accumulator approach here. I'm going to delete this doc string just so in the interest of space. And I'm going to say, well, we're looking for divisors, right? And we can accumulate them in a list. We're expecting to return a list, as we saw in the doc string. And I'm just going to say for I in range from 1, right? Because we're not trying to divide by 0. And we're going to go up to half of n, half of whatever that number is, and add 1 to it. So we can do n over 2, and then add 1. So this is just going to be the range of numbers we're checking. And we're doing this because a number isn't going to be divisible by any number that's more than half of itself. so no reason to do that. And I'm going to say if n modulo I is 0, nope, not 9, is 0, then we're just going to append I. And that's kind of it. Pretty straightforward. So let's return the divisors. And let's check this. So let's print find divisors of, let's do 32. And go ahead and run this. 1, 2, 4, 8, 16. That's pretty promising, right? Let's do 93. 1, 3, 31. Cool. That just seems to be working. Let's do 90. Well, no, we'll move on. Okay, so this find divisors function seems to be working. Great. Now, a function that we write quite a bit is the isPrime function. Let's go ahead and write that next. Determines if a number is prime. The parameter is n, which is a positive integer. Same as all these. N is our, it's always going to be a positive integer here. And it's going to return true or false, right? A number is either prime or it's not prime. It's going to return a Boolean. So I'll go ahead and delete that docstring in the interest of space. Okay, so def is prime. I like to cover this base case first. If n is 1, return false. No reason not to do that. And mind you, there's a number of different ways to solve this. I'm going to solve it in kind of a standard, standard easy way. Keep in mind there are other ways to solve this that look a little cleaner, act a little cleaner, maybe a little more optimized, but we're not worried about that here. We're more worried about understanding. So for I in range, and since we already eliminated the 1 case, because every number is divisible by 1, we don't want to think about it, we're going to go from 2 to n over 2 plus 1. Remember that division will make something a float, so let's just do int of n over 2 plus 1. And if n modulo I is ever, if n modulo I is ever equal to 0, right, between 2 and half of the number, then we're going to return false. That's going to be, that means it's divisible by something, and otherwise we're going to return true. So let's call this print is prime. Let's call it on 91. And I'll clear the terminal, and let's find out, is 91 prime? False. Wait, what's happening here? Is 91 prime? Funny. I should know this offhand. It's semi-prime. Oh, 7 times 13. Oh, great. Okay. You know what? Let's just do a prime number we all know. Let's do 13. True. Let's do 31. True. Okay. So it's finding prime numbers. Let's see. Does it think 27 is prime? It does not. I think we know, if we think about this logically, this is doing its job. So is prime. That's the is prime function. Let's now use the is prime function to write this find next prime function. So again, n is a positive integer, easy enough. Next prime is the next prime number after whatever we've just looked for. So that's kind of a cool problem. If something is prime, then let's find out the next prime number. Now, I'm just going to solve this with a while because even though there is a way to solve this with a for, this is one of those situations where, because we don't know how many times we need to check something, maybe while is logically sensible. Okay, so we have n, and I'm going to make an accumulator. And I'm going to start it off at n plus 1. So this is one more, right? One more than the previous value. So if something is prime, like 37, um, uh, or 31, let's say 31. 31, we're going to start at 32 and go from there. And obviously 32 is not prime. We could actually do n plus 2 here, but let's just do n plus 1 just to sort of seed the idea. And I'm going to say while not is prime of the accumulator, then we're going to just go ahead and increment the accumulator. And this may, so as long as the accumulator is not prime, then we just increment it. Now, it's kind of boneheaded, but it's a way that we could do it. We could do this with a value n plus 2 as well. But let's just do n plus 1. We're going to, it's going to, it's going to take a little bit longer, right? It's going to have more operations, but let's just go ahead and do that because it's simple enough. Return the accumulator, and let's test it. So let's print find not divisors, find next prime, and let's do it on 31. Clear that, and run it. 37. Cool. Let's look at the next one after 37. And 41. And we can keep doing that, right? We could even do something like, well, I won't do it here, but you could write a for loop and, use this cascade of functions to output a whole series of prime numbers, easy enough. Okay, so now that we have these functions, the functions that are required, let's go ahead and run this big block of code that we provided and see how that does. So I'm again going to say, when you write these functions that are being asked, these are find divisors, is prime, and find next prime. When you write those and you get to a solution, you're only going to paste these in, find divisors, is prime, and find next prime, into the challenge box, right? The text box, and you're going to test that. Don't include the prompt, user input, etc. Don't include that when you paste it in, because that will end up failing the tests, because learn won't interpret this. It'll time out essentially, or it'll go to, it'll have an end of line error while it's waiting for this input prompt. So yeah, don't do that. So I'm going to go ahead and run this, and it says, hello, please enter a number and I will perform blah blah blah. And I'm going to enter the number 31, and you can't see it here, but it says 31 is prime, 37 is the next prime number, half of that number rounded down is 18, and its divisors are 1, 2, 3, 6, 9. Those are the divisors of 18. So that is working how we'd expect it to. Got the find divisors, is prime, and find next prime functions written, and again, those are the only things that you're going to paste into the challenge in order to arrive at a working solution. Thanks.